Welcome back to Cinderella Math. This is for pre-calc or trig, maybe an advanced algebra 2, but probably more into the pre-calc or just a standalone trig class. And I'll be doing some sum and difference formulas. You will want your cheat sheet for trig or your reference sheet. And then you'll also probably want the unit circle if you're allowed to reference that. If you already have that memorized, then that's great. All right, I am using a paper that one of my private tutoring students sent me. So let me grab that. There we go, right here. So the formulas are on her sheet. Because that's kind of close to her name there, I will, well, plus I kind of just don't like how they're written together. I will just Google a cheat sheet, which I already have, and we will look at the sum and difference formulas. Oh, they're together on this one as well. That's fine. I just like them better separately, but it's totally fine. So we're going to be focusing for this video on our sum and difference formulas. Some sheets write them together, some sheets write them separately. These are together. So you read it like this: sine of alpha plus beta. So see how plus is on top? You would just continue to do the top signs. But if we need sine of alpha minus beta, you would just follow the bottom signs. Okay, I'm actually going to pull up Desmos here as well. Sorry, I just got a new computer because my pen thing was not working on my other one. So I really hope it's working now. I'm going to open Desmos as well. Alrighty. Grab your unit circle as well. I don't think I'll pull that up, but you will need it unless you have it memorized. Okay, so even though she's already done some of these, I'm just going to go up on top of her work and do them again. I think she did these in class anyway, so it'll be good to just redo them anyway for everybody. Okay, so the point of the addition or the sum and the difference formulas is to get the exact value of stuff that's not on the unit circle. So you do see it says exact. So sure, could we type that in a calculator, cosine of 15? Yeah, we totally could, but we won't because that's not the exact value. We could get a rounded value, we could get an approximation, but it's not exact. All right, but if you think of unit circle, we have on the first quadrant, it's 30 degrees, 45 degrees, 60 degrees. Well, they're asking us for cosine 15. So that would be like here. That's not on unit circle. That's not something we can just pull the PDF of unit circle and find, and it's not something we have memorized. So this is our goal. We either need to find two thingies. I'm going to call them A and B. You can say alpha and beta, or I just like A and B, that will add to 15 where both of these are on unit circle, or we can do A minus B where that should come out to 15, where again, A and B or alpha beta are both on the unit circle. So I didn't white this out because my student already did it, but you can see here her work, 45 minus 30, that's 15. Is 45 on the unit circle? Yes. Is 30 on the unit circle? Yes. So from memory, or if you're using a reference sheet for unit circle, let's go ahead and write down those points. So 45 degrees is root 2 over 2, root 2 over 2, and 30 degrees is root 3 over 2, 1/2. And then I go like this, CS, CS. All right, now we will go to our trig cheat sheet, and we did a minus. We let A be 45 degrees, B be 30, because 45 minus 30 is 15. So we're going to go to our cheat sheet, and we did a cosine minus. And why cosine? Because that's what we're after here. Okay, so coming to our cheat sheet, I might have to, let's see if I can get this all on. There we go. All right. I am circling in pink. We want this one because we're doing a cosine, and we want the minus. So we'll be following the bottom symbols. So cosine, we're going to say A plus B Same thing as alpha and beta. Oh, no. We're not doing the plus. We're doing the minus. Sorry. A minus B equals cos of alpha, which is A, cos of beta, which is B. And again, we're following the bottom symbols because minus was on the bottom, so we're following the bottom, plus sine of alpha, which is A, sine of beta, which is B. You can do the alpha and betas. It's just, some people get weirded out by the Greek, so I'll just do it that way. Okay, we usually do not memorize these formulas. Usually you are allowed a reference sheet, cheat sheet, whatever you want to call it. So we just jot that down. I would jot it down every time. And now let's come back to our paper and let's actually work this out. So ours is cosine of 45 degrees minus 30 degrees equals cos of A, so cos 45, cos of B, so cos 30, plus sine of A, so sine 45, sine B, so sine 30. And now let's just come over to unit circle and get those. So cos of 45 is root 2 over 2 times cos of 30 is root 3 over 2 plus sine of 45 is root 2 over 2 times sine of 30 is a half. Multiply first because of order of operations. Root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. These have a common denominator, so we could combine them into a jumbo fraction, root 6 plus root 2. Don't combine those, right? If radicals don't have the same radicand, we can't do that. So just leave it like that, all over 4. That is the sine of 15 degrees. Nope, cosine. Losing my mind. Cosine of 15 degrees. And if we pop to Desmos, here's how you can check this. It won't just straight up tell you the exact answer, but you can check the decimals. So first, let's change our Desmos into degrees. I'm going to have to clear this for a second. Changing Desmos into degrees. So we had cos of 15. And then our answer was fraction square root 6 plus square root 2 all over 4. And let's see if they're the same ugly decimal. Yes, it is. We got this correct. Do you have to check? By all means, no, but that is how you could. Just make sure you do hit the wrench and change your Desmos to degrees. If you're using a handheld, you can still check. Just make sure you switch it into degree mode. All right, I'm coming over to number 2. Actually, I'm going to do all the degrees first, and then we'll switch to radians. The radians are a little harder. Oh, there was only 1 degrees. Okay, never mind. We'll switch to radians. Coming to number 2. So we have sine of 7 pi over 12. So again, either you've memorized unit circle or you can pull out your copy of it or look up a PDF of it on Google, whatever. 7 pi over 12 is not on there. Like pi over 2 is, and that would be 6 pi over 12, right? So 7 pi would be like right there. It is not there. You can look at unit circle all day long. You're not going to find it. So what we need to do is come up with 2 radians that are on unit circle that either add to this or subtract to this. And now there's sometimes one person will find an adding one and one person will find a subtracting. So there is a little leeway here. So we need to find an A plus B that will be 7 pi over 12 or an A minus B that will be 7 pi over 12. Again, it kind of doesn't matter. You kind of do what's easier for you. Usually the adding is easier, but not always. All right, ignore the pi for a second. Just think about 7/12. What could give us 7/12? Well, how about 3/12 plus 4/12? Whoops. And then just bring back the pi. That would work, right? 3 plus 4 is 7. Yeah. This reduces though, right? 3/12 is a fourth. So this would be pi over 4. Yeah, there's a 1 there, but we don't write it. And this one reduces as well. 4 over 12 reduces to 1/3 or pi over 3. Again, there's a 1, we just don't write it. Are these both on the circle? I'm going to let that be A, that be B. Yes, they are. Either you've memorized circle or you're looking at your reference. Pi over 4 is the middle one right here. It's the same as 45 degrees. So that's root 2 over 2, root 2 over 2, CS. And pi over 3 is one up from it right here. It's 60 degrees. Pi over 3. And that point is 1/2 root 3 over 2, CS. So yes, we have found our goal. We have found 2 radians that add to 7 pi over 12, and both of them are on the circle. So our A is going to be pi over 4, and our B is going to be pi over 3. Those could be switched, by the way. It would still work. And we are doing a sine, because that's what the problem wants, and we found an adding. So we're going to go to our reference page, and we're going to find the formula for sine adding. Come back here. Right here, and we're going to follow the top symbols because it's sine adding. So sine of A plus B or alpha plus beta equals sine A cos B, and again, follow that top sign, cos A sine B. All right. So now we don't need the formula sheet anymore. Going back to the paper. So we have sine of pi over 4 plus pi over 3 would be, again, this is A, this is B. So sine pi over 4 cos pi over 3 plus cos pi over 4 sine pi over 3. And then we just use our unit circle knowledge or reference to fill all that in. Sine pi over 4, root 2 over 2. Times cos pi over 3 is 1/2 plus cos pi over 4, root 2 over 2, times sine pi over 3, root 3 over 2. Multiply across the top, that would be root 2. Across the bottom would be 4. Across the top would be root 6. Across the bottom would be 4. Again, they have a common denominator, so we can do a jumbo fraction. Root 2 plus root 6 over 4. Yes, that is what we got on number 1. That's a coincidence. And again, we can check. I'm not going to check all these, by the way. So that was sine of 7 pi over 12. I'm going to clear this for a second. I'm going to hit the wrench. I'm going to switch decimals back into radians. And I'm going to say sine of 7 pi over 12. And then we're going to do what our answer was, which was square root 2 plus square root 6 all over 4. Yes, it matches. We did it correctly. That's how you can check. Awesome. Coming down to sine 5 pi over 12. So again, if you consult your unit circle, 5 pi over 12 is not on there. You can check it all day long. You won't find it. So goal. Let me actually not white out toward the very far because that's where our formula is going to be. Okay. Here's our goal. We either need to find A plus B that will equal 5 pi over 12, or we need to find A minus B that will equal 5 pi over 12. And again, both of them have to come from unit circle. So now what? Let's think of our unit circle. What could add to 5? Well, 1 plus 4. So we could say 1/12 pi plus 4/12 pi, but this one's not on the circle. 1/12 is not there, so that won't work. What else could add to pi? Or excuse me, 5. 2 plus 3. Let's try that. What if we did 2/12 pi plus 3/12 pi? That would be 5/12 pi. If this reduces, 2/12 is a 1/6, so pi over 6. And again, yes, there's a 1, but that's fine. Is that on the circle? Yeah, pi over 6 is the first one up, 30 degrees. Pi over 6. That point is root 3 over 2, comma half. Ooh, let me not run off the edge there. Root 3 over 2, comma half. And then how about the next one? This reduces 3/12 is a fourth, so pi over 4. Is that on the circle? Yes, it is. It's the middle one in quadrant 1. Pi over 4, which is root 2 over 2, root 2 over 2. So we've done it. We've met the goal. This is going to be A, well, the reduced, and this is going to be B. These two together add up to 5 pi over 12. Okie dokie. So we found an adding, and this is a sign. So we're going to go back to our reference sheet. We're going to go sign, adding, which I think is the same that we just did previously. But again, no one memorizes these. We just always go back to our sheet and copy it down. So at the top right of my screen here, we're going to do sign with the top because we're doing adding. So we have sine of A plus B is sine A cos B, and pick the top sign, plus cos A sine B. Okay, that's all we need the formula sheet for. Go back and plug in chunk. So we have sine of pi over 6 plus pi over 4 equals sine of A, which is pi over 6, cos of B, which is pi over 4, plus cos of A, which is pi over 6, sine of B, which is pi over 4. Sorry for kind of squeezing that in there. I'll come down here for a little more room. So we have sine, oh no, what is sine pi over 6? So go back to your unit circle, or you might just have this memorized. That's the one I had to draw down there in the blue. So sine is a half. Cos of pi over 4, that's up there in the green. That's root 2 over 2. Plus cos of pi over 6, that's down there in the blue. That's root 3 over 2. And sine of pi over 4 is root 2 over 2. So this would be root 2 over 4 plus root 6 over 4, which is the same answer we've gotten before. That is a coincidence. It's okay. There we go. That is sine 5 pi over 12. Coming over to Desmos, sine of 5 pi over 12. Yep, still good. Awesome. Clearing off. It's coming over to number 4, tan of 7 pi over 12. Tan is the worst one. Okay. We have already done a 7 pi over 12, so I'm going to kind of skip the goal part. And before we had 3 pi over 4, no, 12, plus 4 pi over 12. That will equal 7 pi over 12. So we're going to let this be our A, this be our B. They could be switched, right? Because adding, you could switch. It's fine. Reduce. So 3/12 is a fourth, or pi over 4. That's going to be our real A. Reduce 4/12 is pi over 3. That's going to be our real B, and we're adding. So we need to go to our cheat sheet and find tan for adding. Again, we never memorize these, and typically, unless you have a really mean teacher, we can always just look here. Scrolling down right there. All right, so we're doing tan with adding. I'm going to put it in a box, and we're going to be following the first symbol because it's adding. So tan of A plus B. Again, some people get scared by the Greek. If you're not scared by the Greek, feel free to use them. Equals tan of A, top symbol, plus tan of B over 1, top symbol, minus tan of A, tan of B. Okay, there's our formula. And again, we followed the top symbols because we were doing A plus B, and plus was on the top. So we kept following the top symbols. All right, back to our sheet. All right, unit circle. Again, not needed if you've already got it memorized. See, A is pi over 4, which is root 2 over 2, root 2 over 2. And b is pi over 3, which is this one, which is 1/2 root 3 over 2. Okay, but look at our formula in the red. We need tans. Unit circle gives us cosine and sine. So remember, tan, you can either remember tan is y over x. So this is x, this is y, and you can do it that way. Or you can remember that tan is sine of your angle over cos of your angle. They're the same thing. Y over x, sine over cosine. So let's get tan of pi over 4, the blue one. So that would be root 2 over 2, the y value, over the x value, root 2 over 2. Well, that's a number divide itself. This would just cancel out to 1, right? And now this one's going to be a little uglier. Let's do tan of the orange one, which is pi over 3. We're doing the y value, root 3 over 2, divide the x value, 1/2. Now this one's not going to cancel out, so we need to divide these, but we don't really divide fractions. Go all the way back to middle school. We keep, we change, we flip, keep, change, flip. These are going to cross cancel, and we get root 3 over 1. Anything over 1 is just itself. Okay, now we can finally actually do this problem. So going into that red formula, it says we need tan of A. So we need tan of pi over 4, because that was our A, plus tan of B, which is pi over 3, all over 1 minus tan of A times tan of, oops, but what's our A? Sorry. Pi over 4, tan pi over 3. Okay, but we've already worked all that arithmetic out. We just need to plug it in. So we have tan of pi over 4, so 1 plus tan of pi over 3, root 3. And then on the bottom, 1 minus 1 times root 3. So this would give us a final answer of 1 plus root 3, 1 minus, because 1 times this would just be root 3. You are typically allowed to leave roots on the bottom here. If you have a really uptight teacher, you might have to bounce it off, but 9 times out of 10, we can just leave them. Okay. Coming to number 5, another tan, okay. 17 pi over 12. Oof, okay, so we need to either find two things that, oh, let me not cover up the top because that's where our formula will be. We need to find two things that will either add to that or subtract to that, because if you look at your unit circle, 17/12 is not on there. Okay. So we need A plus B is 17/12, or A minus B to be 17/12. Okay. So what can give us 17? Well, 10 plus 7. But if you look on unit circle, 7/12 is definitely not on there. So that won't work. What else gives us 17? 8 plus 9, and then that could be over 12. That could be over 12. Yeah, that would work. Okay, what do these reduce to? 8/12 you can divide by 4 and get 2/3 pi. And 9/12 you would divide by 3 and get 3/4 pi. Let's let this be A, this be B. Are those on unit circle? I think so. Again, you either have this memorized or you're looking at a reference. 2/3 pi is here. It's in the second quadrant, kind of the uppermost one. This is 2/3 pi. This point is -1/2 root 3 over 2. And 3/4 pi is the middle one in the second quadrant, this pink, 3/4 pi. Its point is negative root 2 over 2, root 2 over 2. Okay, so now we figured it out. We did find an A and a B where both of them are on unit circle. Added together, they come out to 17 pi over 12. So now we need to jot down the formula for tan, and we did an adding. So that's the same formula we had a second ago. It was tan of A plus B is tan of A plus tan of B all over 1 minus tan of A times tan of B. So I just remembered it from the previous question. Of course, you could look on the reference sheet. Okay, but our A is 2/3 pi. Okay, so we are going to have tan of 2/3 pi plus tan of B, which is 3/4 pi, all over 1 minus tan of A, but our A is 2/3 pi, times tan of B, which is 3 pi. Now, back to the unit circle, it does not give you tan. So from the previous question, remember tan is y over x or sine of your angle over cos of the angle. Either way, it doesn't matter. So this is x, this is y. So for tan of 2/3 pi, we'll do √3/2 divide -½ We'll keep, we'll change, we'll flip. √3/2 times 2/-1. These will cross cancel and we'll get √3 divide -1, which is -√3. So that's going to be our tan of A. So anywhere we have that, we could go ahead and put that in. So -√3 plus something, 1 minus -√3 times something. Okay. Now we need to get the tan of our B, which is 3 pi over 4, the pink one. So tan of 3 pi over 4. Again, this is the x, this is the y. You do y divide x, or if you think of it this way, cosine sine, you do sine divide cosine. So that's √2/2 divide -√2/2. But this one's easier. That's a number divide itself. That's going to just cancel out to 1, but watch out for that negative sign. It's going to be -1. So anywhere we see tan of B or tan of 3/4 pi, let's put in -1 and there as well. All right, I'm going to clear off so I have room to do my arithmetic. Pause me if you need to. Oh, sorry. All right, so we have -√3 and then see plus or minus. Y'all know that's just -1. And then we have 1. And then these two multiplied would be positive. So it'd be 1 minus just a normal √3. Yeah? I think so. I would say answer there. If you want to like zhuzh it a little, you could multiply this one by a negative and say that's regular √3 plus 1, and then 1 minus √3, or 1 plus √3, 1 minus √3. It's fine. Let's check that one. That was tan of 17 pi over 12. Okay, and we got fraction 1 plus, I'm doing that very last answer just because it's prettiest, but they're all fine. 1 plus, let me clear this off. 1 plus √3, 1 minus √3. Oh, okay. Ooh, I have a different sign. Like it's the same answer, but the second one's negated. Let me bring back the work. See if I can catch a sign here. Oh, okay. I don't, that little cheat where I multiplied through by a negative, I did it on the top, but I didn't do it on the bottom. So if you're not going to do it to both, then just don't do it. Let's leave the answer. Don't do that. I just try to clean it up. Don't. This is fine. Let's leave it -√3 minus 1, and then the bottom is fine. Negative. Oh, it's still, oh yeah, there we go. That is correct now. Okay, good. Just that little trick at the end. I shouldn't have tried to do that. I was trying to be cute, but don't. Okay, I think we have one more. Number 6. Oh, this had a degree. I'm sorry. I should have done this earlier, but it's fine. So back into degree mode, which most people think is easier. So we need cos of 165. So goal, if you look at unit circle, there is no 165. So our goal would be to get A plus B, where they're both on the unit circle, to be 165, or A minus B to be 165. Okay, I mean 100 plus 65, but neither of those are on unit circle. 120 plus 45. I know 45 is, and I'm pretty sure 120. Yes, it is. Okay, that'll work. So we're going to go with the plus, and I'm going to let that be 120 for our A and 45 for our B, because together that will make 165. Okay, let's think of unit circle. I know 45 is the middle one in quadrant 1. We've used that many times today because that's also pi over 4. And that's root 2 over 2, root 2 over 2, CS. And then 120, either you have this memorized or you look at your unit circle handout. 120 is right here. It's the like topmost one in quadrant 2. So that would be negative half root 3 over 2 CS. And we are doing cosine, and we did it with a plus. So let's come to our formula sheet. Cosine. There it is at the very tip top right-hand corner, putting it in a blue box. And we need the plus, so we're going to follow the top symbols. So we have cos of A plus B equals cos of A, cos of B minus, because again, that's the top sign. We follow the top signs because we did plus here, so we're following the top. Sine A, sine B. Okay, that's all we need the formula sheet for. Okay. Alrighty, so we said our A is 120, so we're going to have cos of 120. Let me write it where I can have a little more space, sorry. I'm coming down, I'll still be in the pink pen. So cos of A is going to be cos 120. Cos of B is going to be cos of 45. Minus sine of A, so sine 120. And sine of B, which will be sine 45. Sorry for squishing there. Okay, going to unit circle, cos of 120. That's the blue one, and pick the cos. So that's negative half times cos of 45. That's the green one, so root 2 over 2. Minus sine 120. That's root 3 over 2. Times sine 45. That's root 2 over 2. So this would be negative root 2 over 4 minus root 6 over 4. So we have negative root 2 minus root 6 all over 4. Answer. That is cos 165. I'm going to flip Desmos back into degrees. Cos 165. And then what did we get? We had negative root 2 minus root 6 all over 4. Yep, yay. Awesome. Well, I hope this was helpful on sum and difference identities. Ugh. Maybe I will do number 7 actually real fast. All right, real fast here. This is you're proving it. So they've already done this one. They just want it to show. Okay. So this is sine with a minus, where this is our A and this is our B. So we need to get the formula for sine of A minus B. Let's come back over to our sheet. Okay, at the very tip top, the sine one, tip top right, and we're going to be following the bottom signs because we want minus. So that would be sine A cos B minus, because we're following the bottom signs, cos A sine B. Okay. All right, but our A is X. Look at our original problem there on the printed sheet. So everywhere we see A, let's put X. So sine X, cos B. Cos our B is 3 pi over 2 minus cos A, so cos X, sine B, so sine 3 pi over 2. Okay, unit circle, 3 pi over 2 is straight down. Right here, this is 3 pi over 2, which is over nothing down 1, CS. All right, so now we have sine X. Cos of 3 pi over 2 would be 0 minus cos X. Sine of 3 pi over 2 is negative 1. 0 times anything, this is gone. Negative times negative would be positive. So bye-bye. Cos times 1 is cos. And there we go. We did it. We proved it. And this pen, I literally bought a new computer. Like legit, this computer is an hour old and it's not working. So that's great. It worked for a while. Anyway, all right. I hope this was helpful on sum and difference for trig and that you're having a great day. Bye-bye.